Hello from Earth. My name is Marshall Eubanks. I'm with Space Initiatives Inc. I'm the CEO. And I'm here today to talk about Ringside Seats Landing Assist, which is a new program we have that we're actually demoing at the LSIC meeting that's going on in Johns Hopkins APL. Ringside Seats is based on our Mote penetrator. Here is a Mote penetrator flight test article. This has actually been fired from a cannon. That's a lot of fun. You can see it's been scored here. It's been qualified to land on the lunar surface at velocities of up to a few hundred meters a second. This thing can have instruments. It's been fired live with instruments. Has a tail section with an antenna and a camera on it. So in Ringside Seats, we would have 4 on a lander. The lander would have our deployer. We've tested that as well. It's based on a CubeSat deployer, so it's pretty straightforward. It just has the different form factor you need for the penetrator. These could be on the lander legs or the lander body. Doesn't really matter for us. And then as the lander comes in, typically it's moving horizontally, killing its horizontal velocity, and at some points it pitches over and it has basically no horizontal velocity, and it's looking down. Terminal navigation then picks out a nice flat place to land on. So about the time of the pitch over, when the typical altitude might be a kilometer high, we will be deployed. It would take about 30-35 seconds for us to reach the lunar surface from that altitude, from 1 kilometer. We'd hit at about 60 meters a second of velocity, which we've tested this, in fact, tested this very unit, and they survived just fine. And then once it lands, which is typically about a minute before the lander lands, maybe a little longer, depending on the lander profile. Once it lands, it sets up a mesh network. They talk to each other, the penetrators do. They talk to the Panakin box, that's a pocket cube sized box, 5 by 5 by 5 centimeters, up on the lander. The Panakins and the penetrators are doing all the computations for for Ringside Seats. We do not rely on the lander computer at all for computation. Of course, this is a busy time for a lander computer, so you don't want to tax it. We will not be taxing it at all. We'll be sending it data, but we will not be asking anything of it. And they will determine the position of the lander. We have done numerical calculations, simulations, where we think with both trilateration from optical imaging and ranging from 802.15 for ranging, we can determine the lander position to a meter relative to our penetrators. So if the lander has a horizontal velocity, we can determine that. If the lander is going down too fast vertically, we can determine that. And we can get imagery of the landing process itself. So this is Ringside Seats. We'll be on the floor of LSIC, so come by and see us. And we're easy to find if you're interested in this, if you're a lander provider, or if you're interested in it. I mean, yes, it'll be a payload subtraction, a mass of about maybe 10 kilograms. This is a kilogram or so, depending on its payload. But it's a lot cheaper than a failure of a landing. So give us a call, send us an email. Thank you very much, and have a good day.